My name is Charles Kaplan. I'm a professor at the State University in New York at Old Westbury, and this is the 8th video on the chain rule, and the last several have dealt exclusively with trig functions. The first few did not, and then I have a few that dealt with trig and non-trig functions, and then these last 2 or 3 are exclusively trig functions. I actually recorded a video with this particular problem in it, and then I realized as I was finishing the video that I could do it much more efficiently, that there was a faster way to solve this problem, and I'm going to show it to you in a moment. In the meantime, let's review the derivatives of trig functions. The derivative of sine theta is cosine theta. The derivative of cosine theta is negative sine theta. The derivative of tangent theta is secant squared theta. The derivative of secant theta is secant theta times tangent theta. The derivative of cosecant theta is negative cosecant theta times cotangent theta. The derivative of cotangent theta is negative cosecant squared theta. And I want to remind you that secant is equal to 1 over cosine, cosecant is equal to 1 over sine, and cotangent 1 over tangent. Now, having done that, let's take a look at this problem. So, f of x equals cotangent x divided by sine x. Let's go ahead and differentiate this thing using the quotient rule. And let me just remind you about the quotient rule. The quotient rule, where we have f of x divided by g of x. We're going to take the derivative of the numerator, which is f prime x, and multiply it by the denominator, which is g of x. We're going to subtract off the derivative of the denominator, which is g prime x, times the numerator, which is f of x, and we're going to divide it by the denominator squared. So there you go. There's the quotient rule. We take the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator divided by the denominator squared. Okay. Let's move on. Here's our problem. Obviously a quotient rule problem. So, f prime x. The derivative of cotangent is negative cosecant squared theta, so it's negative cosecant squared x times the denominator, which is sine x, minus the derivative of the denominator, so it's the derivative of sine, which is cosine x, times the numerator, which is cotangent x. And we're going to divide everything by sine squared x. Okay. Next. Cosecant squared x. Cosecant is 1 over sine. So let's rewrite this as negative 1 over sine squared x times sine x minus cosine x. Well, cotangent, let me just move that over on a separate piece of paper here. Cotangent x is equal to 1 over tangent of x. And tangent is equal to sine over cosine. So 1 over tangent of x is equal to 1 over sine x divided by cosine x, which is equal to cosine x over sine x. If you want, we can multiply it by the 1. But this is what ultimately cotangent x is equal to cosine x over sine x. Okay? So I'm going to use that fact and make a little substitution here. So here's where we were. And I was multiplying this by cotangent x. And therefore, I'm going to multiply it by cosine x over sine x. Okay? And everything's divided by sine squared x. A song should be written with, that's the refrain. And everything's divided by sine squared x. Okay. F prime x is equal to, well, this becomes negative sine x over sine squared x minus cosine squared x over sine x, and everything's divided by sine squared x. Okay, let's pull this. Can we see this? Okay. So, moving forward, f prime x, negative sine x over sine squared x is negative 1 over sine x minus cosine squared x over sine x, and everything's divided by sine squared x. Okay. So now, let's go further, f prime x. Let's combine these terms, the numerators, above one common denominator. So we have negative 1 minus cosine squared x divided by sine x, and everything's divided by sine squared x. Okay, let me get this out of the way. Move this up. Okay, now f prime x is negative 1 minus cosine squared x over sine x times, well, the way we handle a compound fraction is we invert and multiply. So we're multiplying by 1 over sine squared x. So f prime x is equal to, well, negative 1 minus cosine squared x times 1 is just negative 1 minus cosine squared x. And sine squared x times sine x is sine cubed x. And that's it. We cannot go any further. Now, I'll just explain something that you may be tempted to do, but it won't work. And I'll explain why in a moment. But this is it. This is the solution. This was a more elegant solution, or not a more elegant solution, but a more elegant workout. Here's the original quotient that we want to differentiate. And what did it take? 1, 2, 3, 4, 5, 6, 7 steps, including the final step. And we probably could have, knocked out 1 or 2 of those steps. It dawns on me that some of you will see this. Negative 1 minus cosine squared x over sine cubed x. And you will be reminded of the fact that cosine squared x plus sine squared x equals 1. And so 1 minus cosine squared x equals sine squared x. And this is what's resonating in your heads. However, there's no way to make this look like this, the numerator. If we factor out a -1 from this guy, it becomes -1 times 1 plus cosine squared x. You'll see that this actually does have some meaning, but it's not relevant here. Okay? Let me scooch that up a little bit. There's no way to make this numerator in the solution equal to the, this was the, if you recall, this is the Pythagorean identity, the one we start with, and then if we want the other two Pythagorean identities, for one we divide through by cosine squared x, and for the other one we divide through by sine squared x. But in this particular case, this is the answer right here, and there's no way to turn it into really anything else and make this thing meaningful in any way. So that's it. This was video number 8 of the chain rule videos. My name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury. I hope you found this video helpful, and I hope you find all my other videos helpful. This is the 8th of about 8 videos on the chain rule, and you can see other videos up on the internet on calculus and linear algebra, ordinary differential equations, probability and statistics, econometrics, and so forth. I hope you found this helpful. I wish you all good health and happiness. Bye-bye.